Hello, good evening. Welcome to my channel. Today's problem is 3272. Find the count of good integers. So, given two positive numbers n and k, an integer x is called k palindromic. X is a palindrome, and x is divisible by k. So, an integer is called good if its digits can be rearranged to form k palindromic integer. For example, for k equals to 2, 2020 can be rearranged to form k palindromic integer 200. Whereas 1010 cannot be rearranged to form k palindromic integer. Return the count of good integers containing n digits. Note that any integer must not have leading zeros neither before nor after rearrangement. For example, 1010 cannot be rearranged to form 101. Input n is equals to 3, k is equals to 5. For this example, for this input, some of the good integers are 5, 5, 1. So, because it can be rearranged to form 515, and 515 is divisible by k, and it is also palindrome. So all the permutations of this 515 will be also considered as a good integers. 5 to 5 is 5 to 5 because it is already k palindrome. And for example, they are given one here, one digit. So one digit number which is divisible by 4. So if one digit, every digit is palindrome. So 4 and 8 are the answer. So for example, a 5 is there. So then also k is there. So for this input, there are 2, 4, 6. These many of integers, good integers. So coming to the code part, this is a function. This is a function main calling function. So count good integers. So first we have give a listed stored all the valid palindromes, list of strings, and also care of integer care of arrays base palindrome. So then I will generate all the palindromes within the range. So I will start from zero index and k. So this is my base case. So I will iterate to the every input. For my example, n is equals to 3. So in a sense there will be 3 digits. So three digits. So my index will be at 0, and I will iterate to the one by one. I will iterate one by one. So for index is equals to 0, and my base case would be if my index crosses like first it will be 0, 1, 2. So it after it is crossing the middle of the mid length, then I will I will convert the char to the string, and also parse the palindrome which is equals to 0. That is to the valid palindromes I will add and return. So this is my base case. So my uh, recursive call would be if index is not equals to 0. So this is not my first case. The current index is equals to 0. Current number of current it is equals to 0. Mirror it. Generate palindromes. I will calculate all the palindromes for this. That is when my index not equals to 0. So first I will see whether my index then my index will be 0. So I will calculate the index of length is equals to 1, and last digit will be also 1. The symmetric digit also will be 1, and I will call the generate palindrome. So I will recursively process all the and process all this and traverse to the index integer array to the one by one. So this for one I will this is, so then I will process 0 also. So then I will call this function also. So I will use all the 0 I will use 1 to 9 I will use. So I will also all calculate all the palindromes available with the length n with the length n palindromes are stored, uh, and like after my store unique frequency patterns. So store unique frequency pattern, I will count the store frequency pattern. For each valid palindrome, generate a frequency pattern. Suppose there are the frequency valid palindrome is there. So string palindrome. I will one by one iterate through the valid palindrome. Count the frequency. Count the frequency of all the palindromes. And after calculating the frequency, I will count frequency into pattern string like hash. Count frequency number to a letter. So I will count the frequency. It will be in the number format. So wherever it will be in the number format. So I will count to the letter format and append it to the pattern. So unique patterns dot add pattern dot string pattern to the string. So I will add pattern total character pattern to the string. So these I will do one by one, whatever palindromes we have calculated. Then after doing this, we will calculate the factorial, the total factorial. N for 3-digit numbers of what is the factorial? What are the permutation? What are the how many ways of how many permutations we can achieve? So in that case, we will using the permutations, we will calculate the answer. Total permutations were there, and initially we have calculated the patterns. So we will check here whether pattern is so there are conditions also here. So pattern should not start with any leading zero. Leading zero should not have any leading zero, neither before nor after replacement. So it should not be like before zero should not be there. We will make sure that that part also calculate this one. And also we will count all the palindromes. So you can see my code and understand this part on your own. And now this is my full code here. I will try to submit this code. Yeah, it is executing. Thank you for watching. Thank you for watching my channel. Uh, like and please like and subscribe to my channel.